There's been many platforming games made with Box 2D over the years, but there hasn't been any specific support for platforming games other than a few callbacks and things like capsules, for example. I decided to spend some time and add some more direct support for character movers in Box 2D. And in particular, I've been working on a dynamic character mover. So this mover is a real rigid body. And so it's designed to interact with other rigid bodies and help make platforming games that are more kind of rigid body oriented, physics oriented. So let's go over some of the features. So you can see there's a capsule, and that capsule is a rigid body with fixed rotation, and it stands on what I call a pogo. So it's this line coming down that meets the ground and kind of represents the feet of the character. Uh, so there's a number of things going on here. First of all, there is a constraint that controls the side to side movement, and that is done sort of like a motor joint, but it has a simpler setup. It's just a velocity command with a maximum force. So that gets us our side to side movement, and it doesn't constrain the vertical at all, the motor part at least. But then there's also this pogo constraint, uh, yeah, that I've added for the feet, and that knows how to um, make the character slide along the ground and keep the distance while sort of softening out that movement. And then in the character mover code that I'll show you in a little bit, it has a lot of features around traditional kinds of acceleration and friction for character movement. There's things in there that handle if a surface is walkable or not. So this steep surface on the left is not walkable, so I slide down. And yeah, you can see it all kind of works like a rigid body, um, but there's a lot of affordances for traditional character movement. And because the the movement is done with a rigid body and the pogo is done as a constraint, the forces of interaction are still grounded in the rigid body solver. So gravity is pushing the bridge down just because it's a rigid body, not because of some arbitrary downward force. I've also added some support for one-sided platforms and taking into account the surface velocity. This kind of shows how to use the pre-solve callback to get that one-sided collision. And you can see with the Pogo, it provides this smooth movement on stairs. And so that's its main purpose, is to provide that smooth movement. You can see this line coming out of the capsule to the side. That's uh, that's just the velocity vector. I'm using that just to help with understanding the movement and the acceleration and things like that. And because it's a rigid body, it can block other rigid bodies and interact with them as you would expect. And because Box 2D has built-in continuous collision between dynamic bodies and static bodies, you pick that up for free with this character mover. All right, let's look at some code. This is the code for the sample that you just saw, and in there you can find all the details of how to hook up this dynamic mover. Um, Here you can see the mover being created from a dynamic mover definition. And then you can see in here all the details of setting up that environment and moving the character around. But let's look at the dynamic mover code itself. So that comes as two files, a header and a CPP file. Now all this code lives in the sample application. So my expectation is that you would take this code and just copy it into your game and then modify it to suit your needs, because every game is going to be very particular about how they want the character mover to be. So rather than trying to make up like a one size fits all solution, I'm more focused on trying to create a toolkit that you can use to build out your character and get it to behave exactly how you want. Granted, there are some kind of setup things here, what I've already done with like the specific constraints that I'm using. So if those don't fit your game, this may not be for you, but it may give you some ideas about what you might do. Okay, so moving on from that, so here's here's the header file, and you can just interact with that mover here. But the interesting parts are in the source file. So in the source file, I'm creating the mover body, and that has a fixed rotation using the motion lock. And then also in here, I'm creating this new joint, this mover joint. And that is, like I said, it's kind of like a motor, but all it has is a velocity command and then a maximum force. So it's going to try to move at this prescribed velocity, but it won't exert more force to do that than what you've specified. Now for this joint, you need a ground body. I just create a dummy ground body up here. It doesn't have any collision on it at all, but maybe in the future you would add collision to it, so uh, you would want it to collide. But it doesn't really matter what this ground body is as long as it's a static body. Its location doesn't really matter. All right, let's look down here. Now, there's this update function, and that's going to be called by your game every time step. And one of the first things it does is this downward raycast to represent the pogo. Now, this raycast has a predetermined length, but it has a step down length as well. Right now, I'm just using the pogo length, so it's basically twice the pogo length. And that step down is going to help keep the mover stuck to the ground as it's going down slopes or going down stairs rather than just falling all the time. So I take that raycast result and then I use that to create this new pogo joint. This joint is like any other joint in Box2D, except how it's used. I decided I didn't want to do the raycasts in the joint because the kind of raycasts you might want to do for a mover can have a lot of variation. You might have a lot of rules. You may have fallbacks. You may do multiple casts. You may do shape casts. So I didn't want to restrict that. So instead of doing those casts in Box2D, they're done externally here, and then this pogo joint is set up from that result every time step. So it's destroyed and recreated every time step. So let's look at some of the things in here. Uh, it's got the spring length. It's got the spring hertz and damping ratio. It also has a compression force, so that's what's holding it up. So it could be squashed if there's a heavy thing pushing down. And then there's also a tension force, which keeps it from leaving the ground. So if you're not jumping, that pogo is actually sticking you to the ground. But if you are jumping, that tension is set to 0, so the pogo is free to leave the ground. Now, because the pogo is recreated every time step, I set it up so that you can transfer the impulse and velocity of the pogo across frames. So this when it's creating the pogo, it's copying in the old pogo impulse and the old pogo spring velocity. So that uh, helps the pogo perform better and have kind of a history, even though it's being created and redestroyed every frame. All right, that's it for now. I hope you find this useful, and please give me your feedback.